welcome to This Explainer. I'm your host, the strategist, and today we are tackling absolutely the ultimate challenge in your academic journey, the Cambridge 9618 Computer Science exam. Now, I want you to think of this syllabus not just as a standard test, but as a mental Olympic decathlon. It's a grueling event that requires endurance, adaptability, and total mastery over multiple, very distinct disciplines. We are definitely not just looking at basic, surface-level definitions today. No way. We are zeroing in on one of the most rigorously tested and, frankly, frequently misunderstood topics in the entire curriculum, touchscreen technology and its principal operations. If you've been grinding through past papers lately, you already know the exact tension I'm talking about. You sit down, the clock is ticking loudly in the background, your palms are maybe a little sweaty, and suddenly, boom, you're faced with a high-mark question demanding a deep architectural breakdown of how a touchscreen processes inputs. It's not just asking what it is, it's asking how the hardware and software talk to each other. It is the ultimate test of your technical precision. So, let's get focused, let's get highly strategic, and let's decode exactly what the principal examiners are actively looking for when they grade your paper.
Okay, let's dive right into this. What exactly separates an A-star candidate from a B candidate when dealing with touchscreen technology? It's a high-stakes question, right? And honestly, the answer might actually surprise you. It isn't about who can memorize the most textbook definitions about capacitive grids or resistive layers. You can memorize the entire textbook and still get a B. The principal examiner reports are crystal clear on this fact. The real difference comes down to execution, logical structuring, and conceptual application. Think of it like this. A B-grade candidate knows what a touchscreen is and can describe it. An A-star candidate, they can systematically deconstruct the algorithmic flow of coordinate data. They can evaluate the efficiency of the processing algorithm, and they can perfectly link it back to the very specific scenario provided in the question prompt. They don't just see a screen. They understand the underlying mathematical and physical matrix. They see the code beneath the glass.
So here is our masterclass framework for today. We'll be moving through 5 crucial steps. 1. The A-star difference. 2. Core principles. 3. The method mark strategy. 4. Critical analysis. And finally, number 5, we'll cover the top examiner warnings. Let's start with Section 1, the A-star difference, and the really common pitfalls students face when writing about principal operations. Whether you are transitioning up from the foundational IGCSE syllabuses, like the 0417, 0478, 0983, 0984, or the 2210, or maybe you are already deep into the AS and A-level 9618 framework, the initial shock of the mark scheme can be incredibly intense. We regularly look at the legacy code 9713 or the current 9618 past papers, and you know what? The story is always exactly the same. Students have the knowledge locked in their heads, but they completely fail to translate that knowledge into the specific, structured format the examiners are legally bound to reward. It's like having all the puzzle pieces but putting them together upside down. Let's actually look at a live example of how this plays out on exam day. Here we have a dynamic split showing 2 very typical student profiles tackling a complex touchscreen data question. On one side, we've got student Alex. Now, Alex is a hard worker, right? But Alex overloads answers with raw computer science facts, writing these massive, dense paragraphs detailing the exact chemical composition of a capacitive screen, just dumping every single piece of knowledge onto the page. But guess what? This yields 0 marks for analysis because the answer is completely unlinked to the scenario. It's just an encyclopedia entry. On the other side, we have student Sam. Sam absolutely knows the material but panics under the timer, rushes the answers, and completely misses the command word requirements. If the question specifically says evaluate, Sam just describes. Both of these students lose massive marks, not because they don't know computer science, but because they don't know exam strategy. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acedexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Theoretical Principles. You absolutely have to move beyond rote memorization. Academic benchmarks for touchscreen technology's principal operations require logical, structured, step-by-step reasoning. The Cambridge Assessment Framework heavily prioritizes analytical depth over superficial breadth. So what does that practically mean for you in the exam hall? It means top-tier students connect touchscreen principles to totally different syllabus areas. For example, you need to ask yourself, how exactly does the analog-to-digital converter interface with the touchscreen matrix? How do hardware interrupts physically signal the CPU that a touch is actually registered? Principal examiner reports highlight time and time again that candidates who reference these cross-topic connections achieve significantly higher marks. It shows you understand the whole ecosystem, not just an isolated component.
Let's break down the specific computer science assessment objectives you're up against. You are basically being tested on 3 distinct cognitive domains. First up, knowledge and understanding. This is your baseline level, just recalling that a touchscreen uses sensors to detect changes in electrical currents or physical pressure. Second, application to unfamiliar contexts. This is huge. The exam won't just ask, how does a touchscreen work? That's too easy. They will ask something like, how would a capacitive touchscreen function in an automated ticketing machine at a freezing outdoor train station in the middle of winter? You have to take the theory and apply it to that specific weird scenario. And third, deep analysis. This is where you dissect the complex, invisible interactions between the physical hardware and the processing software. Which brings us to a really vital definition you need to internalize: algorithmic thinking. In the context of touchscreens, this requires step-by-step decomposition, appropriate data structure selection, efficient code implementation, and rigorous testing. So let me pose a question to you that the senior examiners often debate. Why do so many smart students find evaluating algorithm efficiency so incredibly hard? Well, it's because they view the touchscreen as some sort of magic hardware, rather than a systematic system executing a continuous loop. An A-star student visualizes the algorithm running in real time. They picture the system scanning the x-axis, then scanning the y-axis, calculating the specific coordinates, checking that against an interface array, and finally executing a hardware interrupt to the CPU. If you can break the physical hardware operation down into a logical software algorithm, you unlock the highest possible mark bands. It's a total game changer. Now, let's look at Section 3, the method mark strategy. This is your procedural framework for flawless execution. Listen closely, because in advanced computer science papers, examiners award marks for the procedural logic itself, not just getting the final answer right. Systematic processing is totally mandatory. If you follow a standardized, logical sequence, you secure what we call method marks. These are points awarded simply for showing the correct analytical pathway, even if your final conclusion slightly misses the mark at the very end. This is literally how you build an unbreakable safety net under your grade. It ensures that even on a tough question, you're scooping up points. We use a very specific memory hack acronym to systematically process touchscreen technology questions, and I want you to memorize this. Let's walk through DESEP. First, D, deconstruct the question. Literally take your pen and underline the command word. Is it asking you to explain, analyze, or evaluate? Second, E, extract the data. Pull the specific scenario details out of the prompt. Third, S, select the framework. This is where you apply the Peel framework: point, evidence, explanation, link. It's the ultimate structure for your paragraphs. Fourth, E, execute notation. Write out your analysis with extremely clear step-by-step working. And finally, P, present terminology. Ensure you are using precise, high-level phrases like analog to digital conversion or coordinate matrix instead of basic words. If you run every single question through this DESEP processor, you will guarantee your method marks. Seriously, take 60 seconds in your next practice paper to actively map this out before you even start writing your answer. It completely changes the game. Let's put this into practice with a data interpretation challenge. Data interpretation skills are absolutely critical here. You need to handle binary extraction by identifying boundary conditions. You need to perform calculations by showing your step-by-step working clearly. And you must draw conclusions by providing solid, evidence-based insights. Imagine a really complex touchscreen data log showing hundreds of coordinate inputs. Your job isn't just to blindly read the data. Your job is to extract the core trend. Are the inputs exceeding the screen boundaries? Are there dead zones where touches aren't registering? This detective-like analytical mindset is exactly what transforms a generic, boring response into a top-tier analysis. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's shift our focus now to Section 4, Mastering Critical Analysis. This is all about elevating your evaluation skills so you can finally access those higher-order cognitive domains that examiners love to see. We are going to do a rapid-fire mental workshop right now, so stay with me. When you see an evaluate command word regarding touchscreen technologies on your paper, you absolutely cannot just list features. That's a trap. You have to perform a comparative analysis. Think of this as a speed-writing interactive workshop taking place right in your mind. You have to construct a paragraph that not only presents the raw data, but weighs it critically against the alternatives. Look at this comparison right here. A standard candidate simply lists basic similarities. They might write something like, capacitive and resistive screens both register touch. I mean, it's true, but it's incredibly basic. It earns minimal, foundational marks. The A-star candidate, however, identifies similarities and differences, and they do it using comparative connectives. Let's see what they write. Whereas a resistive screen relies on mechanical pressure to bridge two conductive layers, rendering it durable but less optically clear. A capacitive screen measures changes in electrical charge, thereby allowing for multi-touch capabilities and greater light transmission. Do you see the massive difference there? They perfectly used the Peel framework: point, evidence, explanation, and crucially, they linked it all together using comparative connectives like whereas, thereby, and conversely. That is how you write an A-star answer. And this brilliantly illustrates exactly what the examiners mean when they ask for evaluative thinking. It requires 4 very specific actions on your part. 1. Considering multiple solutions. Don't just look at one angle. 2. Analyzing trade-offs, like discussing the high cost versus the extreme durability of different screen types. 3. Acknowledging limitations. For instance, pointing out that a capacitive system struggles heavily in wet environments or if the user is wearing thick gloves. And 4. Justifying decisions with evidence. You must provide a justified recommendation at the end. Don't just say one technology is better. Explicitly state it is better because of the specific constraints of the scenario provided in the prompt. This is the complete computer science answering system. Combine this structural approach with a time management matrix where you allocate exactly 1 minute per mark on the paper, and your exam performance will completely transform. We have officially reached Section 5, Top Examiner Warnings. This is where we look at the direct, unfiltered insights straight from the Principal Examiner reports for Cambridge 9618. These are the giant red flags, the exact areas where literally thousands of students bleed unnecessary marks every single year. We've synthesized all this dense data, and I'm going to give you a rapid-fire rundown of the top 3 absolutely critical errors you must avoid at all costs. All right, here they are. Warning 1. Answers on touchscreen technology operations are way too vague. Examiners do not want general wishy-washy summaries. They demand specific, hard technical details. Don't just write, "it sends a signal," that's too simple. Say, "the microcontroller generates a hardware interrupt." Warning 2. Students completely forget to check boundary conditions and edge cases during algorithmic analysis. You need to ask, what happens if 2 fingers touch the screen simultaneously? What happens if the touch is exactly on the coordinate boundary line? Warning 3. Answers are not specific to the context given in the question. If the exam question is about a life-saving hospital heart monitor, your answer cannot be about how a teenager uses a smartphone. It has to match the context. Fixing these specific pitfalls yields massive results and is often the exact differentiator between grade boundaries. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. I want to leave you with this incredibly powerful directive, a direct quote summarizing the ultimate examiner alert. The classic mistake is providing generic answers. Always link every point to the given scenario. That right there is the absolute golden rule of Cambridge computer science. You have the theoretical foundation, you have the method mark DESP strategy in your toolkit, and you know exactly how to leverage the Peel framework for critical analysis. The only question left is, when you sit down and that exam timer officially starts, will you react like a stressed student relying purely on memorization, or will you execute flawlessly like a true computer scientist? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.